Okay, I hope I'm audible to all students who are attending this lecture of Intermediate Microeconomics Part 2. We intend to discuss some of the questions in this lecture from Assignment 1 based on the concept of Pareto efficiency and market equilibrium. Okay, so let's look at a few practice questions from this particular assignment. Okay, so let's first of all start with numericals based on Pareto efficiency. Now we have covered the concept of Pareto efficiency in our lectures on general equilibrium. And if I quickly revise with all students, an allocation in the Edgeworth box is said to be Pareto efficient if no one can be made better off without making the other individual worse off. That means once you reach the Pareto efficient allocation, you have no incentive to deviate from there, because if one of the agent deviates from the Pareto efficient allocation, that is going to become better off at the expense of other individual becoming worse off. Okay, now let us practice a few questions based on finding the contract curve, where contract curve is nothing but the locus of all Pareto efficient points inside the Edgeworth box. Okay, so let's look at the first question from the assignment. We are given two agents A and B. We are given their utility functions. Both have the min utility function. That means both of them have perfect complement preferences. And we are given that the endowments omega-1 and omega-2 are 50, 50. We need to find the contract curve, and we need to repeat the same exercise given the endowments are 100, 50. Okay, so let's come to the whiteboard. Let's quickly solve this question on the whiteboard. Okay, so this is the first question. What we are given are the utility functions of the two agents, which are min of x1a comma x2a, and utility of agent B is min of x1b comma x2b. We are also given the endowments at omega-1, omega-2 are equal to 50, 50 respectively. Okay, omega-1 denotes the endowment of good 1 available in the economy. Omega-2 denotes the total amount of good 2 available in the economy. Okay, so basically our Edgeworth box is going to be a square, because the length and the breadth of the Edgeworth box will exactly be equal to 50 units. Okay, we need to find out the contract curve. Find the contract curve, which is the set of all Pareto efficient allocations. Okay, so let's quickly start. So first of all, let's draw the diagram. So our Edgeworth box is basically going to be a square. Okay, this is the origin of agent A. This is the origin of agent B. Okay, from A side, this is 50. This is 50. And if you turn your pages, guys, from B side also, this is 50. So I will be using the red color for B, and I will be using the black color for A. Okay, so from B side also, this is 50 and 50 respectively. Okay, if you look at A's in different curves, how will they look like? If I draw a 45-degree line, guys, you will see that all the kinks will lie on the 45-degree line. These are A's ICs. Perfect complements means they are L-shaped ICs. Okay, these are A's ICs, and this is the 45-degree line. If you look at B's ICs, I am drawing them in red color. So starting from B's origin, they are going to look like this. When you turn your pages around to B's origin, and when you draw the ICs from B's origin, they are going to look somewhat like this. Okay, so now our objective is to find out the set of Pareto efficient allocations. Okay, so first of all, let's take any allocation on the 45-degree line, because you can clearly see that all the kinks lie on the 45-degree line. So I can write A's kinks and B's kinks clearly lie on the 45-degree line. Now let's take any point on the kink. So suppose I take a point. Suppose A has 1,1, if A has 1,1 and my total is 50,50, which is my endowment, how much will B have, guys? B will have 49,49. What is the utility A gets from his own allocation? Min of 1,1 is 1. What is the utility B gets from its own allocation? Min of 49,49 is 49. Now let's try to make one of them better off. Now I can say to make A better off, suppose I want to make A better off. To make A better off, he needs at least 1 unit. He needs at least 1 unit of both the goods from me. If I want to make A better off, that is possible only when B gives 1 unit of both the goods to A. So B will be left with 48,48. Utility which A gets now is min of 2,2. Utility which B gets now is min of 48,48. Clearly, A has been made better off, but B has become worse off than before after this trade. Similarly, you try to make B better off. To make B, so I can, first of all, I can write that clearly this exchange has made A better off, but B has become worse off. But B has become worse off. Okay, now let's try to make B better off. So I can write to make B better off, he needs at least 1 unit of both the goods from A. He needs at least 1 unit of both the goods from A. Now suppose A does that. Suppose A gives 1 unit of both the goods. So we are starting with this allocation, okay? Suppose A gives 1 unit of both the goods, then A will be left with 0, 0, B will be left with 50, 50. Utility which A gets from its own allocation is min of 0, 0. Utility which B gets from its own allocation is min of 50, 50. If you compare this with this, B has become better off, but A has become worse off. So I can write again, this exchange makes B better off by making A worse off. By making A worse off than before. So guys, what can I say? I can say that this initial allocation is Pareto efficient. The initial allocation, which is 1, 1, 49, 49, which lies on the king, is a Pareto efficient point, because we have seen that when we have tried to make A better off, B is becoming worse off, and when we have tried to make B better off, A is becoming worse off. That means none of the parties is going to deviate from this allocation, hence it is Pareto efficient. Now I can generalize and I can say that all the points on this 45-degree line are Pareto efficient. If one point on the Pareto efficient, on the 45-degree line is Pareto efficient, I can generalize, and you can do this exercise at home. Just take 2, 2, 48, 48, 3, 3, 47, 47, dot, 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 49, 49, 1, 1. And guys, even the origins, OA and OB are also Pareto efficient. Because OA also lies on the 45-degree line, OB also lies on the 45-degree line. That means every point on the 45-degree line, including the origins of A and origins of B, are Pareto efficient. So I can erase this particular part and I can write, that therefore every point on the 45-degree line, including the origin of A and origin of B, are Pareto efficient allocations. I just took one point and I show that it's Pareto efficient. You can generalize and you can say that all the remaining points on the 45-degree line are Pareto efficient allocations. Okay, now you can randomly take corner points also and check. Take a point here, take a point here, take a point here, take a point. So suppose I call this as C. Suppose I call this as B. This is point B, this is point C. Now you take a point on, suppose I erase the right hand side and I take a random point on OAC, a random point on. First of all, students understand that in perfect complements, you never have corner solutions at all, because you would not want to disturb the ratio in which you are consuming both the goods. So if you take any point other than the king, for example, you can even take a point other than the king inside the edgeword box. So I can say taking any interior point not lying on the 45-degree line. So I can first of all take a point not lying on the 45-degree line. Suppose I take the point as 2, 1. Suppose A has 2, 1, and suppose B has, what's the remaining left? 48, 49. What is the utility A gets from its own bundle? 1. Utility which B gets from its own bundle, 48. You can see, let's try to make one of them better off. Suppose I try to make B better off. You can clearly see A can give 1 unit of the first good to B. So my allocation will be 1, 1, and B has 49, 49. Suppose this exchange happens. Suppose A gives the first unit of X1 to B. So what is the utility A is going to get now? Min of 1, 1, which is 1. What is the utility B is going to get? Min of 49, 49, which is 49. You can clearly see, guys, B has become better off than before without making A worse off. Therefore, this is not a Pareto efficient allocation. This is not a Pareto. That means this allocation is not a Pareto efficient allocation, because when this exchange was made between A and B, you can clearly see that B had become better off without making A worse off. I can write clearly B has become better off without making A worse off. Without making A worse off. Hence, this allocation is not Pareto efficient. Take any other point. So you can see that this point was lying in this particular region, 2, 1. I took a point in this region. So mark this, suppose, as region number 1. So taking any interior point not lying on the 45-degree line, say a point in region 1. Region 1 is nothing but triangle OA OBC. Region 1, that is triangle OA OBC. So you can clearly see, if I take any interior point in region 1, it's not Pareto efficient. Similarly, I take any interior point in region 2. Okay. Similarly, taking any interior point in region 2, that is, region 2 is given by triangle OADOB. If you look at OADOB, this is my triangle. I take any interior point in this. Suppose I take a point 1, 2. 1, 2 will lie somewhere here. And B has how much left? 49, 48. Again, guys, we can try to make one of the agents better off. So how can we do that? Suppose I make this trade. Suppose A gives 1 unit of X2 to B. So what was the utility A was getting before? A was getting a utility of 1. B was getting a utility of 48. Suppose I again make this trade. What is going to happen? If I erase this particular part, I can write that now A is going to get a utility of 1. A's bundle will now be 1, 1, and B's bundle now will be 49, 49. Again, utility which A gets from its own bundle is 1. Utility which B gets from its own bundle is 49. If you compare, B has become better off without making A worse off. Clearly, B has become better off without making A worse off. So again, all I can say is that any point in region 2 is also not Pareto efficient. So I can say this is not a Pareto efficient allocation. So what we have shown is that any point on the 45-degree line is Pareto efficient. But if I take any random point in region 1, it is not Pareto efficient. If I take any random point in region 2, it is again not Pareto efficient. Where region 1 is my triangle OA OBC and region 2 is my triangle OAD OB. So similarly, you can check, you take any corner point, you take any point on OAC, COB, OBD and OAD. You can clearly see perfect complements anyways don't have corner solutions at all. So I can say what is my answer for this question? The only Pareto efficient contract curve is this line. So the brown line, which all of you can see on your screen, the brown line, this is my contract curve, which is the set of all Pareto efficient allocations, including OA and OB. So the answer for this question is the 45-degree line is the contract curve for this question. Okay, hoping students have understood this. And what was the second part asking you? If I erase this off, the second part to this question was asking you that given that utility of A is min of x1A, x2A, and utility of B was min of x1B, comma x2B, and now the endowments are given to us as 100, 50. The endowments are now 100, 50. So now it's my Edgeworth box is going to be a rectangle. So if you look at, if I draw the Edgeworth box, it's going to look somewhat like this. Okay, this is my origin of A, this is my origin of B. From A's origin, this is 100, this is 50. If you turn your pages to B's origin, from B's origin, this is 50 and this is 100. Remember, I always use the red color for B's origin and black color for A's origin. Okay, now if I draw A's kinks, where will the A's kinks lie? So suppose this whole is 100, suppose this is 50. My midpoint is 50, corresponding to it, this is also 50 from B's origin. So my A's kinks are going to lie on this 45-degree line. So my A's ICs are going to look like this. Okay, and similarly, how will B's ICs look like? If you turn your pages around to B's origin, from B's origin, it's going to go till 50. And B's ICs are also going to lie on the 45. From B's origin, guys, this is the 45-degree line. This is the 45 degrees from B's origin. If you turn your pages, it is going to somewhat look like this. So this is how B's ICs are going to look like from B's origin. So the black ICs denote ICs from A's origin and they represent A's preferences. The red ICs are ICs from B's origin and they represent B's preference. Okay. Now let's look at the Pareto efficient allocation. So again, first of all, let us look at points on A's kinks. Then let's look at points on B's kinks. So consider a point on A's kink. When I talk about a point on A's kink, it means A has, suppose any point I take randomly 1, 1. How much will B have, guys? B will have 99, 49 because the total has to be 100, 50. Now, what is the utility A gets from its own bundle? 1. What is the utility B gets from its own bundle? Min of 99, 49, which is 49. Let's try to make one of the parties better off. So suppose we try to make B better off. So I'm not writing, just understand, let's understand this. Suppose I try to make B better off. Now B needs one more unit here to become better off. Suppose A gives that 1 unit. So suppose we make this trade, and suppose A now has 1, 0, B now has 99, 50. To make B better off, B needs 1 unit here. If A gives that, A is left with 0. Utility of A is 0 now. Utility of B is min of 99, 50, which is 50. Look at this. B has become better off by making A worse off. Similarly, can you try to make A better off? If I want to make A better off, A needs 1 unit here also and here also. Suppose B gives 1 unit of both the goods to A. Then A will have 2, 2. B will have how much? 98, 48. What is the utility A gets? 2. What is the utility B gets? 48. Compare this with this. A has become better off by making B worse off. That means when you try to make B better off in that process, A becomes worse off. When you try to make A better off in that process, B becomes worse off. I can say that my initial allocation is Pareto efficient. That means I can say, therefore, all points on A's kink are Pareto efficient, because both the agents would not want to deviate from there, because when they deviate, then you can clearly see that one of them becomes better off by making the other agent worse off. So I can shade this in brown color. All these points in brown color are Pareto efficient points. I took 1, 1. You can take 2, 2, 3, 3, and you can verify yourself. Now let's look at B's kink. Okay. So consider a point on B's kink. Consider a point on B's kink. If you look at B's kink, guys, now B has 1, 1 and A has 99, 49. And you can use the same logic. Utility which A gets initially is 49. Utility which B gets is 1. Same logic. Try to make A better off. To make A better off, A needs 1 more unit here. Suppose B gives that unit to A. So we have 99, 50 and B is left with 1, 0. Clearly you can see utility which A gets is 50, but utility which B gets is 0. A has become better off by making B worse off. You try to make B better off, B becomes better off only when she gets both the units here. So if that happens, B will have 2, 2. A will have 98, 48. Utility which A gets is 48. Utility which B gets is 2. Compare this with this. B has become better off by making A worse off. So again, I can say that this initial allocation is Pareto efficient, and by that logic, I can generalize and say that therefore all points on B's kink are Pareto efficient. Because once you are on B's kink, you would not want to deviate, because if you deviate, one of the agent becomes better off by making the other agent worse off. So I can shade this in brown color and I can conclude that all points on B's kinks are also Pareto efficient. Now we are left with 3 regions, region 1, region 2, and region 3. Let's quickly take a point on these regions and verify whether we get Pareto efficient allocations in these regions or not. So for that, I erase all this now. And let's take a point in region 1, in region 2, in region 3 to verify whether we get Pareto efficient allocations or not. Okay, erasing this particular part, let's quickly take a point. So let's take a point in region 1. So I can write in region 1, I take a random point. So suppose A has suppose 1, 2. This was 1, 1. A point here would mean 1, 2. How much B has? 99, 48. Because the total should be 100, 50. What is the utility A gets? 1. What is the utility B gets? 48. Let's try to make one of them better off. Okay. Suppose I try to make B better off. Then B needs 1 more unit here. Suppose A gives that unit to B. A has 1, 1. B has 99, 49. Utility which A gets is min of 1, 1. Utility which B gets is min of 99, 49, which is 49. Compare both. You can see that B has become better off without making A worse off. Therefore, this is not a Pareto efficient allocation. I can say that any point in region 1 is not Pareto efficient. I can generalize this and I can say, therefore, any point in region 1 is not Pareto efficient. Or I can write in a better way, any point in the interior of region 1. Any point in the interior of region 1 is not Pareto efficient. Guys, from the previous part, we have seen that anyhow, from part A, we saw that you will never have a corner solution because we have perfect complements. So there is no point of checking the corners. You only check the interior points within the Edgeworth box. Because when you are at the corner, obviously, when you are at the corner, one of the good is 0. And min of anything with 0 will always be 0. So by that logic, you will never land up on the corner. You will always be in the interior of the Edgeworth box. Okay. Now let's look at region 2. Let us look at region 2. So what happens when you are in region 2? So in region 2, you will see that A has, suppose I take a point here. So this was 1, 1. This becomes 2, 1. B has how much? 98, 49. Utility which A gets from its own allocation is 1. Utility which B gets from its own allocation is 49. Okay. Let's try to make one of the parties better off. So suppose I want to make B better off. How will B become better off? If B gets 1 unit here, B becomes better off. Suppose A gives that unit to B. Then we have this allocation. Utility which A gets now is 0. Utility which B gets now is 50. You can clearly see B has become better off by making A worse off. Similarly, try to make A better off now. A becomes better off if A gets 1 more unit here. Suppose B gives that unit to A. Then this will be my new allocation. Utility which A gets is 2. Utility which B gets is 48. Compare this with this. A has become better off again by making B worse off. That means my original allocation is Pareto efficient. And by generalization, I can say that therefore, any point in region 2, is Pareto efficient. You take up any point in region 2, that is going to be Pareto efficient. Okay, take any point in region 3. So I erase this particular part off. Let's take up a point in region 3 and verify whether it's Pareto efficient or not. Okay, so in region 3, let's take a point. So region 3, if you turn your pages to B's origin, what would a point look like from region for region 3? Now from B's origin, guys, this will be 1, 1. So if I take a point, say 1, 2, 1, 2 from B's origin will lie somewhere here. If this is 1, 1 from B's origin, then this point will be 1, 2 from B's origin. Then how much will A have, guys? 99, 48. Utility which A gets from its own bundle is 48. Utility which B gets from its own bundle is 1. Try to make one of them better off. If I have to make B better off, B needs 1 unit here. Suppose A gives that 1 unit to B. So A will now have 98, 48. B will now have 2, 2. Utility which A gets is 48. Utility which B gets is 2. Compare both. B has become better off without making A worse off. Not a Pareto efficient allocation. So I can generalize and say, I can say that therefore any point in region 3, is not Pareto efficient. So guys, what is my contract curve? My area of Pareto efficiency is nothing but this parallelogram. And you can clearly see I'll even have this particular part. You can take a point. Suppose I take a point here. Suppose this is 30. So take a point and you can verify this. The whole parallelogram is your region of Pareto efficiency. Suppose I take a random point to verify this. So I take a point. So this is, suppose A has 30, 0, and suppose B has the remaining, which is 70, 50. What is the utility A gets? 0. What is the utility B gets? Min of 70, 50, which is 50. Try to make one of the parties better off. Suppose I try to make A better off. A needs 1 unit here to become better off. Suppose B gives that 1 unit to A. What is the utility A gets now? 1. What is the utility B gets? 49. Compare both. A has become better off by making B worse. Similarly, guys, try to make B better off. B needs 1 unit here, but A can't give that unit to B. So anyhow, you can clearly see, because A anyways has 0. He can't further give any unit to B. So again, you can see that this is the point of Pareto efficiency, because starting from this bundle, when I deviate, A has become better off by making B worse. Likewise, you can take a point here. That means, suppose I take a point from B's origin, which is 30, 0. So A will have how much? 70, 50. Again, utility which A gets is 50, utility which B gets is 0. And now again, try to make one of the parties better off. Suppose I try to make B better off. B needs 1 unit here. Suppose A gives that 1 unit to B. Utility which A gets is now min of 70, 49. Utility which B gets is 1. Compare both. B has become better off without making A worse, by making A worse off. That means this is also a Pareto efficient allocation. This is also a Pareto efficient allocation. So what do we learn? You can clearly see that my Pareto efficient allocation or my contract curve is nothing but OA. Let me call this as C, point C. Let me call this as point C, and let me call this as point D. So my answer for this question is that area OA, not area actually, I can write that region OA COBD is Pareto efficient. This is my contract curve. OA COBD. This parallelogram which is being formed is my Pareto efficient allocation. And even every point in the interior of it is also Pareto efficient, including the corners. So hoping all students have understood question 1. Let us do one more question for the day, and after which we can stop. Question 2. Okay, so if you look at question 2, again we are given utility of agents A and B. They are perfect substitutes, x1a plus x2a, x1b plus x2b. Endowment is 50, 50. Find the contract curve. So if I quickly come to the whiteboard, this is a very easy one actually. Question 2. Utility of A is x1a plus x2a. Utility of B is x1b plus x2b. My omega 1, omega 2 is 50, 50. Okay. And if I quickly draw the Edgeworth box, guys, if you look at utility of A, it is x1a plus x2a, perfect substitutes. This is perfect substitutes. And what's the MRS? -1, which is the slope of the indifference curve. Similarly, guys, utility of B will be x1b plus x2b. Again, perfect substitutes. And if you look at MRS of B is also equal to -1. So I can write, since both ICs have the same MRS, I can write A's and B's ICs overlap in the Edgeworth box, because both are having the same slope, so they are going to overlap. So if I draw a diagram, the Edgeworth box, it's going to be a square. It's going to be a square because endowments are equal. A is origin, B is origin. This is 50. This is 50. From B's origin also, this is 50 and this is 50. Okay. And if you look at the ICs for A, they are going to be downward sloping and again 45 degrees, because if you look at the slope, it's -1. So these are A's ICs. They are all parallel to each other. Perfect substitutes ICs are all downward sloping straight lines. All these ICs are parallel to each other. And if you draw these ICs, guys, they are exactly going to overlap A's ICs. So my B's ICs are also overlapping. The red color you can see, it is overlapping with the black color. That means A's ICs and B's ICs overlap. And if they overlap, now you can take any point, guys. Take a point in the interior of Edgeworth box. Consider a point in the interior of Edgeworth box. Take any random point in the interior. Let me call this as C. Let me call this as B. Take any point in the interior of Edgeworth box. Suppose A has 30, 20. Then how much will B have? 20, 30, because they should sum up to 50, 50. That is my endowment. What is the utility A gets? 30 plus 20. What is the utility B gets? 20 plus 30. Try to make one of them better off. Suppose I try to make B better off. Okay. So now if you try to make B better off, B becomes better off either by getting 1 unit here or by getting 1 unit here. Now, if A gives any of the unit to B, then A will become worse. So we can clearly see that. Suppose B gets 1 unit here. So A will now have 29, 20. And B will now have 21, 30. So what is the utility A gets? 49. What is the utility B gets? 51. Clearly, B has become better off by making A worse. Similarly, you try to make A better off. You do this exercise. Suppose B gives 1 unit to A here. So how much will A have now? 30, 21. How much will B have? 20, 29. Utility which A gets is 51. Utility which B gets is 49. Compare both. You will see that A has become better off by making B worse off. That means this allocation is Pareto efficient. No party would want to deviate from this, because if they deviate, one of the agent becomes better off by making the other agent worse off. So guys, by generalization, I can say therefore all the interior points in the Edgeworth box are Pareto efficient. To take any point and verify. And then take any corner. Let's take the corners, okay? To verify whether the corners are Pareto efficient or not. So take any point inside the corner, on the corner, okay? Suppose you take a point here. So I can write on A's x-axis. On A's x-axis, A has, suppose, a random point. I take 30, 0. B has 20, 50. Utility which A gets is 30. Utility which B gets is 70. Try to make one of them better off. Suppose I try to make A better off. So suppose B gives 1 unit here. So A has 30, 1, but B has 20, 49. Utility which A gets is 31, but utility which B gets is 69. Compare both. A has become better off by making B worse off. Similarly, guys, try to make B better off. How will B become better off if A gives any of the units? Now, A can't give anything from here because anyways you have 0. Suppose A gives 1 unit from here. So A has now 29, 0 and B has now 21, 50. Utility which A gets is 29. Utility which B gets is 71. B has become better off by making A worse off. That means all points on A's x-axis are Pareto efficient. And then students, you can verify, take any point on A's y-axis. So if you take a point on A's y-axis, what do you get? If I erase this particular part off, take any point on A's y-axis. On A's y-axis, A has how much? 0, 30, hypothetically. B has 50, 20. Utility which A gets is 30. Utility which B gets is 70. Let's make one of the parties better off. Suppose I try to make A better off. So B gives 1 unit here. So A has 1, 30. B has 49, 20. Utility which A gets is 31. Utility which B gets is 69. Again, A has become better off by making B worse off. Try to make B better off. Now A can't give anything from here. Suppose A gives 1 unit from here to B. This is 0, 29. B has 50, 21. Utility which A gets 29. Utility which B gets 71. Compare. B has become better off by making A worse off. So this allocation is Pareto efficient. So I can say all points on A's y-axis are Pareto efficient. And students, you can verify at home. You can verify that at home that all the points on B's x and y axis, that means this axis and this axis, are also Pareto efficient. So what is my answer? I have shown that all the interior points are Pareto efficient. I have shown that A's x-axis and y-axis are Pareto efficient. You can verify at home that B's x-axis and B's y-axis are also Pareto efficient. So my answer is what? My answer for this question is entire Edgeworth box is Pareto efficient. Entire Edgeworth box is my contract curve. Contract curve, or I can write Pareto efficient. Entire Edgeworth box is my contract curve, or I can say the whole Edgeworth box is Pareto efficient. Okay, so students, this is where I intend to stop. The objective was to discuss, to take up for discussion the first and the second question. Remember, these questions, they take time to solve because you need to take up points and verify yourself. Now in the next lecture, we'll look at discussion from question 3 onwards. Okay, so I hope all students have understood and enjoyed this practice lecture. Any doubt, you can unmute your mic and ask, or call up or mail me your doubts at divineschoolofelconomics@gmail.com. This is where I stop in this lecture.